Hi all of you. Today I am going to discuss one important topic, that is current sensitivity, and also we are going to discuss voltage sensitivity. Some students will confuse in this topic. Okay, so with this class, so you will get one clarity on the current sensitivity and voltage sensitivity. This topic is under the moving charges and magnetism. This topic is related to the galvanometer. And we know that one, what is the galvanometer? Galvanometer is an instrument or electrical instrument. It is used to measure the current, of course, and as well as here what it can detect the current also, we can say that. Why? Because a galvanometer can detect the current, nothing but it can measure a very small current in the order of 10 to the power of minus 9 amperes, we can say that. Means small current can be measured, or small current is also measured a galvanometer. Okay, so in that we have a one topic, that is current sensitivity. Actually, what is the current sensitivity? And it is depends upon which factors, and what is the formula for this one. Actually, if you see the word current sensitivity denoted by here what? Theta by I. Nothing but theta is the deflection of the coil, whatever the coil we are using in the galvanometer. I is the current flowing through that coil actually. Theta by I is called as a current sensitivity. Nothing but for small deflection, or for example here what? For small current, if it is deflects, nothing but a coil deflects more, then its sensitivity is also more. How we can define? If you want to define the current sensitivity, that is a galvanometer is said to be sensitive if it gives a large deflection, even when a small current passed through it. This is the actual definition of this one. Nothing but simple here. In a galvanometer, okay, the coil deflects a large when a small current is flowing through this one. Okay, so this the concept is about the here what? Current sensitivity. So how we can write? Of course, we know the formula of this one. What is the formula of deflecting torque? Torque NBIA. This is equal to restoring torque C into theta. About this one we will discuss in the galvanometer topic. Deflecting torque is equal to restoring torque. Deflecting torque formula NBIA is equal to restoring torque formula C into theta. What is the N here? Total number of turns in the coil, whatever you are using in the galvanometer. B is the magnetic field which is provided to the coil, and I is the current flowing through that coil, whatever the small current we are giving to the coil, that is I, and A is the area of that coil. C is the couple per unit twist, we can say that, otherwise torsional constant also. Theta is the deflection of the coil. From this point or from this relation we can write it as theta by I is equal to NBA by C. NBA by C. Okay, this is nothing but what? Current sensitivity. So we can define current sensitivity theta by I is equal to NBA by C. This is the formula for current sensitivity. So whereas here if you see N nothing but, okay, where what are the terms here? N is equal to total number of turns in the coil, and B is equal to magnetic field intensity or induction, and A is equal to area of the coil, and C is equal to couple per unit twist, or it is also called as a torsional constant. So these are the terms in this formula we have. N is equal to total number of turns, whatever the number of turns are there in the coil. B is equal to magnetic field or magnetic field induction. A is equal to area of that coil, and C is equal to couple per unit twist, or it is also called as a torsional constant. Nothing but, if you see, for more sensitivity, what is the condition I am writing here? For more current sensitivity, what we should do here to increase the quantity of this one? Okay, so this should be increase and this should be decrease. Nothing but number of turns we have to increase in the coil to increase the sensitivity of current sensitivity, and as well as magnetic field which is provided to the coil should be increased. Otherwise, area of the coil also here. In these three terms, if you increase any one, thereby the current sensitivity of the galvanometer also increases. And also, whatever this one, torsional constant, this should be here what? Decrease. By decreasing this quantity, we can increase the sensitivity of the galvanometer. By increasing these three quantities, we can increase the current sensitivity of the galvanometer. So most important, current sensitivity depends upon these four quantities, that too, number of turns, magnetic field, area of cross section. If these three terms, if you are increasing, then its current sensitivity increases. If the torsional constant value, if it is decreases, also current sensitivity increases. So this is the formula and factors on which the current sensitivity depends. Major, it depends upon how many factors? Number of turns of the coil, magnetic field which is provided to the coil, area of the coil, and as well as torsional constant, otherwise couple per unit twist. That is the value, C value. They will provide. This value is constant, they will provide. If the value is more here, current sensitivity is less. To increase the current sensitivity, these three should be increase. This should be here what? Decrease. Most important formula, and this is the factors the current sensitivity depends. Similarly, we will discuss about the voltage sensitivity. That is also important, right? So we will discuss about the voltage sensitivity. Once you see this formula, okay. Next one about the voltage sensitivity. What is a voltage sensitivity? So it is the deflection produced in the galvanometer when a unit voltage is applied across it. So formula is theta by V. So therefore theta by V is equal to, theta is the deflection of the coil, theta as it is. What is the V here? Voltage or potential difference which we are applying across the galvanometer. So we know that one voltage where here I is equal to V by R. Here we can write it as V is equal to I into R. I into R. In place of voltage we can write it as I, current flowing through the coil. In place of R is nothing but resistance of the galvanometer, that is G. Okay. Theta by Ig is the voltage sensitivity formula. Of course, this can be written as theta by V is equal to, in place of here what, this one how we can write? We know that one theta by I. What is the current sensitivity? Theta by I only, where? That is equal to, what is the formula for current sensitivity? NBA by C. Just before we discussed about the current sensitivity formula, theta by I is equal to NBA by C here. In place of this one, if you write the formula of that is, we will get theta by V is equal to NBA by, right? So C into G. This is the formula for voltage sensitivity. Voltage sensitivity. Okay, voltage sensitivity is equal to NBA by C into G. Okay, what is this G here? G is the R, right? Where G is equal to resistance of the galvanometer. Otherwise, coil also we can say that. Galvanometer or coil. Remaining all are the terms, we know that one. Number of turns, magnetic field, area of the coil, and torsional constant. Most important point here, right? This voltage sensitivity depends upon these 5 factors now. Means, as per the formula, for more voltage sensitivity, according to this formula, how we can say that these 3 terms should be here what? Anyone should be here what? Increase. Otherwise these 2 should be here what? Should be here what? Decrease here. Number of turns should be increased. Otherwise magnetic field should be increased. Otherwise area of the coil also, if you are increasing or increases, this sensitivity increases. And as well as C should be decreased. Otherwise G, if it is decreases, then also voltage sensitivity increases. Of course, according to this formula, you can say that out of these 3, if you are increasing the any value, then its voltage sensitivity also increases. But right, if these 2 terms, if you are decreasing, or any value of C and G, if it is decreases, then also the voltage sensitivity increases. But one important point here, okay, voltage voltage sensitivity does not depends upon number of turns. Voltage sensitivity, it does not depends upon number of turns. Of course, it is depends upon the magnetic field and area of the coil. If you are increasing the magnetic field or increasing the area of the coil, voltage sensitivity increases. But if you are increasing the number of turns, voltage sensitivity does not increases. Why? Because it is independent on number of turns. What is sir? According to this formula, we can say that if the number of turns in the coil increases, voltage sensitivity should be increased. But it is not like that. If you see in the denominator, here the G is the galvanometer resistance. Okay, galvanometer resistance of the galvanometer. One important concept, try to understand. We know that one. See here. What is the reason to? It is independent on number of turns. We know that one. R is equal to rho L by A. Nothing but R directly proportional to length of the conductor. Okay? Resistance is directly proportional to length of the conductor. If you are increasing the, right, see here, if N value increases, length of the conductor also increases or not? N is equal to 1 meter, means 1 ton. For example, it is equal to 1 meter. If it is equal to here what to 2 tons, 2 meters. 3 tons, for example, here what 3 turns if it is, and 3 meter, like that. Number of turns increases, length of the wire or conductor also increases. For example, length increases, its resistance also increases or not? So, its resistance also increases. Means, whatever the value of N increases, same value of resistance also increasing here. For example here, theta by V is equal to, if you are increasing here what 2 turns, means number of turns are here what 2, nothing but 2 into N, right? So that is B into A as it is divided by C into its resistance also increases. Its resistance also becomes here what 2 times of here what G. These 2 can be cancelled. We will get here what NBA by C into G. Nothing but if you are increasing the number of turns in the coil, simultaneously resistance of the coil is also increasing. Then it is independent on number of turns. This is the most important point here. That is the point here. Voltage sensitivity does not depends upon the number of turns. If you are increasing the number of turns, length of the coil also increases. According to this one, length increases, its resistance also increases. If resistance increases, for example, if the number of turns are here what 2 turns, and its resistance also here what 2 into something value here. So this can be here what cancel. So then we can say that here what NBA by CG only. So while increasing the number of turns, is there any effect value of here what original value? No here. That is the reason why, right? Voltage sensitivity does not depends upon number of turns. This is the most important point. But current sensitivity depends upon number of turns. This is the point important in voltage sensitivity. Okay, so we have to understand the point, this one only here. Voltage sensitivity formula. Of course, according to the formula, it depends upon these 5 factors. If you are increasing any factor of this one, this should be increased, but it is independent on increasing of number of turns. Okay, this is the concept of voltage sensitivity and as well as current sensitivity. I hope all of you understood. If you are not getting any clarity on any topic, okay, so you can chat here. Based upon that one, I will give the one clarity. Thank you.